recording. Alright, so I've just started the recording now. So what did you miss? Oh yeah, you just missed the definition of simple harmonic motion and then the graph of the kinetic and potential energy for simple harmonic motion. Okay, now the next part. Pendulum, time 2, amplitude 0.04. What's the length? Okay, not that I need to ask. T is 2 pi root L over G. And you're given the 2.
This question 4?
It's continuation of this question.
Okay.
Yeah, it's the next part. It's the B part. Yes? 2B. We just did 2A. So I tell you that that's 2. So somebody give me please the G or the L. 1 over pi squared. That's the L, isn't it? What's that? Is it about that? Come on, hurry up. Snap to it.
G.
Yeah, what did happen?
So
1 over pi squared equals L over G. I can bring the G up. Yeah, so it's just going to be G over pi squared. So that's roughly 1 meter. Should be a little bit less than 1 meter, like 0.95?
0.99.
99, okay. So L equals 0.99 meters. Scroll up to here. To here. Here. You know this formula, right? Yep. What? Yes? No?
I know that, but I just
Okay. Don't make me worry. Alright, so we got now the length. Now, what's the maximum velocity? Now, that's a bit tricky. Not a bit tricky, but the pendulum's doing simple harmonic motion. So if I just draw it here, it's going left and it's going right. And the question says the amplitude is 0.04. So what that means is it's swinging out 0.04 in each direction. You also know that the T is equal to 2. Does anybody remember the formula for omega? It's in the formula book. Does anybody remember it? 2 pi over T. It comes from this formula. T is 2 pi over omega. Yo, wake up. In fact, I think I showed you this one last week, didn't I?
That was when we were covering
the proof. Yeah. So if I put T is 2, what does the omega equal?
half.
Pi.
Yeah. So I got the omega. Okay. Yes?
yeah.
Now, look. Let me show you in the formula book as well. Let me open the formula book. So if you look at the formula book, there isn't a formula for the maximum V, but there nearly is. What's it? You saw it?
Yep.
Are you seeing it really? Not this one, yeah. So V equals A omega cos omega T. What is the biggest that could be?
A1.
No, A omega. Yeah, because the cos can be 1, but there's an A omega in front. So the biggest that velocity could be is A omega. Do we know the A?
Yes.
Yes. Do we know the omega?
Not yet.
We do.
Oh, wait, yeah.
So 0.04 multiplied 3.14, please tell me that.
That is 0.1256.
0.1256.
Yeah.
Okay. When will its velocity be maximum?
When it's at the bottom.
Yeah, but if we're just talking about a straight line, give it to me in that description.
0.
No description. You can give me a sentence, Brendan.
No.
I've seen you do it hundreds of times.
the pendulum ball will be at the origin, in between minus 0.
At the center will do, or at the origin.
Fine.
Right, that was part 3. Do you need to write it down?
Yeah.
It's just at the center or at the origin. Oh, okay. Yes?
Yeah.
Alright, so determine the maximum acceleration now. So if I go back to the formula book, here's the formula for acceleration. What's the biggest x can be?
No, but we need it to be 0. Oh no, it can be 0.
What's, hey, I might go,
The x can be is 4.
not quite 0.04. That's the biggest x can be. So the maximum acceleration will be omega squared times 0.04. Now what's that, please? It should be around about 0.5, 0.45 or something.
0.39.
Okay. Similar logic to part 2 there. Okay, so at which position will the acceleration be maximum? Yep. So again, the English.
Words.
When the potential energy
Yeah, go on, yeah.
be hot.
Ah, so close, so close. Anyone else want to try?
Velocity is 0.
When
No, but the-
energy
Are we
is
talking
zero.
like
Yes, true, but they want you to describe its position. That is true. Well, describe that. Right, so say you're going to give it to me, aren't you? What is it? Describe it.
Talk.
Ah, no, come on. You can do it, say you.
Talk.
You can-
Talk.
Avenue. Be
What?
quiet. So it's going like this. So we all agree that its maximum acceleration will be out here. So describe this position.
0.04.
Describe it.
True, but describe that. Guys, come on.
Can you call it the apex?
No, you're making this more difficult than it needs to be, right? Here's the center.
Yeah.
And if I'm talking about this point or this point, what are they called?
And start.
Yes. At the...
Why didn't you ask me?
Yes, indeed. At the ends. Oh,
See?
yeah. Happy? Alright, so that's part A and B of that question. So now just part C. So you have this mass and it's hung at the end of a string and it causes the string to extend by 15 centimeters and then the mass is pulled down a further 10 and released. So if I draw that for you, this is your situation. You have a spring and it's 300 grams is put at the end of it and the spring causes the spring to extend to 15 centimeters. The mass is pulled down a further 10 and released so to oscillate. So this here is 15 and then there's the weight at the end and it's 300 grams. And then what happens is somebody comes along and they pull it down further, an extra 10. So of course what will happen is it will start to oscillate up and down. So this here would be like the center. And you pull it down past it and what will happen is it will snap back up like this. Yes, exactly. So what would the A be here, the amplitude?
10.
0.10. Because that's how far it's going past the center point here. Anyways, let's see what they ask. the time. Now, if you look in the formula book, look, right there in front of your face, 2 pi root m over k, although we don't know what the k is, so we have to work that out. So how could we get the k? What law would give us the k?
Hooke's law.
Hooke's law. So F equals k delta x. So what does the k equal? F over delta x. Now what's the delta x here?
0.10.
0.10. And what's the F?
The weight.
The weight. So,
But it's not, because when it's down here it must be more than the weight to cause it to snap up. So this is what you do. You look at, the K does not change, agreed? It's the same spring, so it's the same K. So what you do is you look at it when it's here. So what's the F when it's here? Well, the up must equal the down, so now it is the weight. And the weight is 300 times 9.81. But what's the delta X? It's 0.15.
Why?
Because that's the extension. It's 0.15. So look, what you're doing here is you're looking at the beginning. Okay? You got your spring and you hang the weight on it. The weight down will equal the force up. But if you pull this down, will the weight down equal the force up at the bottom here? No. The up will be more, because what happens when you let go? It goes up. So you should look at the beginning to calculate the K. So what is that, Avenue?
19620.
19620. Okay, now we can use that formula. T equals 2 pi root m over k. T equals 2 pi root m over k. What's that?
0.0245
0.024
5
seconds.
6 9.
So 25 then. Alright. So that is the time. Determine the position of the mass 2 seconds after it's released. So we have to use this formula here, the x. X equals a sine omega t. What's the a here?
0.10.
What's the omega? Well, you have to work it out, but it'll be 2 pi divided by the t there. And then what's the time? The t time they want. They said 2 seconds. So tell me what this is. Radian mode. Brendan, do you have a calculator?
When should I know when to put it on radians and when should I know?
Is it 0? And it's in radian mode. It's always radian mode unless it says degrees. Are you 100% sure it's 0? Okay, so that means,
Any calculations, any of them, anything?
safest is in radians. If that's 0, all that means is that the particle is back at the center. So if I look back to my diagram here, that would mean if x is 0, that means it is here at this baseline. So the question asks you, determine the position, and the answer would be, it's at, if you want to describe it like this, 0.15 meters from the ceiling, if you want. 0.15 m from the top. And then the last part is he wants to know, is it going up or is it going down? How could you tell if it's on the way up or if it's coming from the top?
You divide the period by...
No. Much easier way.
Yes.
Well, true, you got a 50-50 chance, but what you can do is you can use this formula for the velocity, because if the velocity is positive, which way is it heading? Up, and if it's negative, it's going down. So, if you still have it on your calculator, Abanoob, all you have to do for me is replace the sine with a cosine will do. Give it to me, give it. Cos fraction 2 pi over 0.025 times 2, that is a positive number, therefore it's going up. Yeah. Part 1 was the time. What happened to Brendan?
It's this dog or something that I keep hearing.
This sounds really annoying.
What's
Really?
You know, I'm getting every second of this intelligent conversation we're having.
I forgot what they were called.
Can't forget the dog.
Oh, yeah.